Are you someone who are building RAG application or want to explore more about RAG and generative AI application? In this video, I am discussing about the common challenges every developer, especially in the generative AI space, RAG application, most of the people face this kind of challenge. Or suppose you really want to explore generative AI or RAG application, then you should know I would say it's a ground principle or it's a foundation that you should know what are the common challenges you have to face and what are the solution around that, how to overcome those solutions, right? So in this video, I'm discussing those common challenges which generally we face as a RAG application development and how to overcome those solutions. So let's get started and let's understand what are the common challenges faced in generative AI application or RAG application. Let's get started. First, I will talk about the architecture, how the architecture are different. Okay, let me talk about the architecture part. So how the architecture of RAG application is different from normal web application. Okay, so in a common RAG application or generative application, let's suppose this is your RAG application. Okay, let's suppose this is your RAG application or Gen application, and suppose this has been deployed into maybe in a cluster in a Docker, right? And this application, it is built around what is called LLM, right? You should have some LLM. It can be any OpenAI, it can be generative AI, Google, it can be any LLM model. So this application talks to LLM. Okay, this is a typical RAG application we built, right? And maybe it can be UI, it can be some users which will connect with the RAG application. They will send some maybe prompt, they can send some input, some query, it can be anything, right? And this RAG application, we know that suppose you're building a RAG application, then it will have its own knowledge base, right? This is a knowledge base. Okay, or it can be connected with the vector database. It can be some vector DB, right? It can be vector DB. So this is a very normal, typical kind of RAG application or generative AI application. Here, so this is the difference between the architecture side. Okay, in a normal web application, what you have just a web application. Suppose it's a web application. It has been deployed into some container or Docker. Okay, it has some UI, it is connecting with that, right? And it is maybe it has some database, suppose have some database, right? This is a typical web application. So here, first of all, I want to draw the comparison between the architecture side, okay, because this is very important. Now let us understand what are the challenges. Suppose you are going to develop this kind of architecture, right? Let's suppose this is the architecture of a typical RAG application or generative application. So what are the challenges? Let me talk about that. Okay, I hope now you are clear about the architecture. So let us understand once you are developing these applications, right? So what are the key challenges you are going to face? Okay, so number one challenge, let me talk about one by one. Okay, so number one challenge is what? The input part. Okay, let me talk about what is input, or you can say the query part, right? Query part. Okay, this is the one of the basic difference between normal web application and RAG application or generative AI application. The input here is not fixed. What is called? It is not a fixed input, right? In case of web application, your input structure or schema is fixed. In case of our normal application, what we do in the website, user either can fill a form, right? They will have a multiple form, and they can submit the form to web application. This is what happened in the typical web application, right? So in the typical web application, your inputs, okay, right? Whatever inputs you are going to send to the your application, that is fixed. Schema is fixed. The meaning is fixed. It can be a fixed length, right? This is a typical web application. But in case of RAG application, in case of generative application, your input is not fixed. It is just like a message, a query, okay? And here the user can send any kind of message. Let's suppose I'm giving example. Let's suppose you have built a chat application, or suppose you have a chat bot, okay? let's suppose you have some application who can suppose agents, suppose you have developed some kind of agents, right? So here the user can send any kind of input, any kind of message, which can be have different meanings, right? There's no fixed schema, no fixed rule that user can send only this kind of message or something like that. So your RAG application, your generative application should be capable to handle any kind of input which is coming from user. It can be integer, it can be some string, it can be any kind of prompt, it can be any kind of message. So this is one of the biggest, I would say, challenge to face by the RAG application or generative application. Okay, here your input is not fixed. This is number one. And number two, after this is let me drag it. Okay, so number two, one second. This is number one, right? Number two is again, number two problem here is again the output. What is that? Output, right? So in the typical web application, your output is also fixed. You know that for this input, I have to generate this kind of output. But in case of RAG application or in case of Zene application, here output is produced by LLM, right? I told in the beginning, right? In the architecture, this is your RAG application, right? And RAG application talk to LLM just to generate some output. And here LLM is not deterministic. It is not a deterministic, right? It can produce any kind of result uh, depending upon the input, right? So here output is not fixed as compared to web application. It can be because LLM is a dynamic, right? It can generate any kind of message, any kind of output, right? So here the problem with this application, testing is a little bit difficult here, right? In the typical web application, you can perform some integration testing, you can do automation testing, right? And you have a fixed data, you have a fixed output that my application is going to generate this output. But here it is not the case. Your output can be completely different, okay, depending upon input. And see here the structure is also not fixed, right? Structure can be any, it can be string also, but here the challenge here is that it is very difficult to predict the output because LLM, it is not fixed, it is not deterministic, it can generate any kind of output. So how to test this kind of application? It's a biggest challenge, right? You cannot do automation testing or integration testing like a web application. It is very difficult to test this kind of scenario, right? So this is the biggest challenge in RAG application. This is number two. Let me talk about number three. What is the number three problems here? So number three problem is the context. What is that? Context meaning. This is very, 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 very important in case of any application based on NLP application or any RAG application, right? Here, see, I'm giving example. Let's suppose you have built a application, a RAG application or chatbot, right? And user is sending, giving this input that, let's suppose, can I get refund in 30 days? Let's suppose this is a message, right? Or let's suppose here again, input schema is not fixed. It can be any variation, any kind of schema. Or user is saying, why refund is not there? Why refund policy is not there? Like something like that. Or you can say that uh, 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 refund uh, refund is possible or not, right? So here I can see that this all having the user is giving the message like refund, it is about refund, but the meaning can be different, right? It can be maybe your knowledge base, right? Maybe your knowledge base having no this kind of information that can I get a return in 30 days. Let's suppose in your knowledge base you have no any context about suppose about the refund policy, or refund is in 30 days policy, or suppose you have a 60 days policy, right? It can be anything. I'm giving one more example, the context meaning, okay? Let's suppose user is saying this, okay? Let me explain one more example. So how it is difficult in these applications, okay? So here, let's suppose users say that this is a very typical NLP problem. Any application context, okay, the meaning can be different. Suppose you're writing that uh, I saw a python. See, you just and try to understand the meaning. I saw a python and got scared. Right? This is one statement. Let's suppose this is one input. Or let's suppose the second input is like this. I love Python. I love Python, right? Here you can see that the Python word, okay, this Python word are used in the both the sentences, but the meaning are different. In this sentence, the Python meaning is what? It is referring to a snake, right? And here it is referring to a maybe a Python a language or codes, or it can be language. Let's suppose you have built an application, and in that application user is sending these two kinds of inputs. So how your application will differentiate that this Python and this Python are not same, though the word wise, syntax wise, word wise, both are same, but the meaning are different. So this is one of the biggest challenge faced by any NLP application or RAG application. But we have a solution for that. We have an embedding for that. What is called embedding? We do there are a lot of embedding algorithm models are there. So I'm just talking about these challenges. Okay, these are some common challenges faced by this application. So the thing is, your context meaning can be different, because it's not a your input is not fixed, your output is not fixed, your input context meaning can be different, right? So it is not same as web application. So your application should handle this kind of scenario. This is number 3. Okay, number 4, I want to talk about latency. This is very, very important. Okay, latency is very important, because I discussed in the beginning, right? Suppose this is your RAG application, this is your generative application, and you're talking to LLM, which is not, maybe suppose it may be hosted somewhere. This application, your RAG is hosted in, suppose in one instance, one container. This can be out of a network LLM. Okay, suppose you're using OpenAI or Google AI. Suppose you OpenAI or Google, you can use any kind of LLM. So here, this call is going through network, right? So here this LLM can take some time to generate your output, generate a response. It can take your time. Maybe you're depending upon the prompt, depending upon your parameter, it can be anything. How you have configured the LLM, what are the hyperparameter you're using, right? Depending upon that, it can produce the result, and here the latencies can be different, right? So here in this application, the RAG application is very important to trace. It is called, we have to use some tool, right? Some tools to trace. It is called tracing tool. Okay, there are multiple tools which helps us to trace the call, that if I'm calling the external LLM, then how much, what are the parameter I'm sending, right? And how much token it is generating, right? And how much it is taking time to produce the result. So latency is an important aspect. If you're designing a system like this, then you have to think about your application should be good. Users should not feel that they're getting response very late. So how to handle latency? It is very important. Okay, so we have to design a system such that, okay, it's another key challenge. So as a architect, as a developer, you have to tackle this all thing. Okay, latencies. Okay, number 4, which I want to talk about in this list, which is very, very crucial, is about, it is called, let's suppose I'm giving example. Let's suppose this is your RAG application, right? And this is your knowledge base. Suppose you have put your knowledge base, okay? And suppose a query is coming into a system from user, right? So for this, against this query, we have to find the correct or accurate context, right? Or you can say document from the knowledge base, from the vector database. This is what happened in a typical RAG application, right? So how to ensure that the context which I'm getting from this knowledge base, this context is the accurate context? How to ensure that I'm getting the right document? Because if your context is not accurate, and let's suppose you are sending this context to LLM, then LLM may not produce good result for you. Okay, so in any typical web RAG application, it is very important to ensure that against the query, right, your context is accurate. It is called uh, though we have a we use a lot of tools just to make sure that I'm getting the right context. Okay, it is called context sensitive or context precision. Okay, so what is your context precision, so that you are able to get the right context? It's a challenge. Okay, there's a solution for that. I'm not talking about this, it is not possible. There's a challenge, there's a solution for that, but it's a typical challenge that every reg application we have to handle. How to ensure that my context is very precise, I'm getting the right context. Otherwise, if your context is wrong, then LLM will not produce the right result. This is a challenge. How to handle it? What is the solution for that? There are a lot of tools for that. I'm not going to talk about that, but these are the challenge we have to face. Okay, this is number 4. Number 5 challenge, which very important, is the, let's suppose your this is your RAG application, as we discussed. This is your LLM, right? So, and this is your query, right? The query is coming into system, right? So an LLM is finally giving you a response. It is generating a response, right? So how to ensure that whatever query I'm sending, and for this query, what is the response I'm generating, corresponding response, right? How to ensure that this response is accurate, or it has a good precision according to the query. Because LLM, I discussed, right, as per architecture, LLM is not a deterministic. It is not a fix. It can hallucinate, right? It can produce wrong result if your knowledge base is wrong, right? You're not giving the right It can be multiple scenario where LLM cannot produce the right response according to the query. So how to ensure that the response which I'm getting against my query, it's an accurate response? Okay, so another, we have a tool for that. I'm not saying it is a quite possible. We can do a testing. We can ensure that the response which I'm getting, it is very accurate as per my query. But this is a challenge. Okay, I'm not giving a solution here, but I'm talking about the challenge. This is a challenge in any RAG application, to ensure that you're getting the right response as per a query. To getting the right context from the vector database, this is also a challenge. To get the right response from the query for LLM, it is also a challenge, right? To ensure that LLM is giving a response promptly, there's no latency, no gap, this is also a challenge. Your input is a challenge. Input is not fixed, output is not fixed, right? The context meaning, it can be different. The user can have a different context meaning. It can be a lot of, these are some challenges. Okay, and number 6 challenge I'm talking about now is the model. This is a very common challenge, is model drift. Okay, what happened? Let's suppose you have done the training, right? You have done the training. Suppose this is your RAG application, this is your gen application, and you have deployed into, suppose, oh, this is your production server. Okay, you have deployed in this server, and it has been tested with some knowledge base. This is your KB knowledge base, and it has been tested with some query. Okay, let's suppose once you trained it, once you deploy it, it is giving you good result. Initially, maybe 1 month, 2 months, it is giving a good result. Okay, but here the challenge here is that this I discussed in the beginning, right? The input side, right? Because here input is not fixed. The problem is with the RAG application, your input is not fixed. This schema is not fixed, right? So here, suppose because that totally depends upon the environment, right? It totally depends upon the user, that what kind of query they are searching for, what is the contextual meaning. It can be different, okay? And maybe over a period of time, right, it is possible that user can change their sentiment, the query can be different, the prompt can be different, they can use something, suppose some keyword, something which your RAG application is not able to handle. So over a period of time, what happens, your model, the performance of your model start degrading. Let's suppose initially when you deploy it, maybe your performance is, let's suppose you have done all the matrices, let's suppose performance is 90%. Initially, suppose you're getting 90% accuracy, your model. But over a period of time, it is possible that because of user nature, because of prompt, because of different input message, different contextual meaning. It can be, this totally depends upon the environment, depending upon the user input. Okay, maybe after some time your accuracy from 90% it can go down. It can, let's suppose it can go 80%, 70%. It can go down. Maybe your prompt is not enough to handle those input. Maybe your LLM is not able to handle to generate response. It can be multiple scenarios, multiple edge cases, right? So that is why it is very, very important in RAG application or in general application to monitor what is called monitor the application. Okay, so we have a lot of tool to monitor the metrics, different matrices of your our like our precision. What is my precision? What is my accuracy? What is my context? Whatever I'm getting the document from the vector database is accurate context. So there are multiple matrices. We can monitor it. We can ensure that. Okay, and you can put some alert also. Suppose your accuracy is going down. Maybe suppose you have put some threshold that if it is go below 85%, then I will send alert. Okay, so this kind of monitoring is very important. This is one of the biggest challenge which I'm talking about, the model drift. Okay, so the conclusion is that maybe during training your model is performing very well. It is giving you 90% accuracy, but depending upon environment, depending upon input, there could be multiple cases where your model will start degrading, your performance will start degrading. To how to monitor it, so it's a biggest challenge. Okay, so these are some biggest challenge I discussed in this video. And trust me, it is not exactly, it is not one thing. I want to make one statement that RAG application is not equal to normal wave application. Both are a lot of different. Okay, because I have worked in both cases. I have seen web application in using Java. I have seen RAG application using this LangChain, using this LLM. Okay, so I find a lot of big gap between web application and RAG application. The As I discussed in the beginning, the difference are in terms of architecture side, difference in terms of their schema, their input, their output, their accuracy. And RAG application use its own knowledge base, its vector database. So there are a lot of edge cases where it differ from web application. So that is why there are a lot of challenges. I discussed this in this video. Okay, but there's a solution. Whatever challenge I discuss about that, there's a solution. You can insert those. You can build that solution, and you can pretty much you can monitor your application. Okay, so maybe in the next video I will come with a new video where I will discuss with you that how to monitor. This is a very important topic. Okay, monitoring part. Okay, monitor. So maybe in the next video, I will create another video where I will discuss how to monitor your RAG application or any GenN application, so that you make sure that your application performance is not poor. Okay, it is not getting poor, and you can monitor your application in the production environment. This is very, very important. Okay, but yeah, these are some challenges I discussed in this video. I hope you like this video. You got some important insight. If you like this video, then please subscribe my channel. It will help me to grow. Okay.